Good evening. I'm Utkarsh Misra, and this is my term presentation for EE Science 2 Electromagnetism. So today's topic is Hall effect transducers, and let's get into the presentation. So first of all, what are transducers? So transducers are simply devices that converts one form of energy into another form. In our case, it will be magnetic field into electrical signals. Let's look into what are Hall effect. What is Hall effect? So Hall effect is a physical phenomena found by Edwin Hall in 1879, and what it basically does, it is based on the force that a charge feels when it is an external magnetic field. So if you can see in this basic setup, we have a conducting strip through which a certain current is flowing, which means charged particles, electrons are flowing through it. There's an external magnetic field, which is uh, which is applying a force on these charged particles, which is equal to Q into V cross P, and is deflecting the charged particles onto one side of the strip. Now, as more and more charged particle will flow through this uh, elect- through this conducting strip, one side of the strip will be more concentrated with the electrons, and the other would actually be concentrated with holes or positive charge. So due to which there will be an electric potential between the two sides, which we call Hall potential. And if we put a potentiometer at the edges, we can measure the potential difference between the two sides of the electric strip. Now let's move into our bread and butter of this presentation, which is the Hall effect transducers. So as shown in the previous slide, we have a Hall strip, as we call our conducting strip, through which a current I is flowing through, and external transverse magnetic field is being applied to the Hall strip. Um, by the presence of a magnetic field, the electrons that are flowing through the Hall strip will concentrate on one side of the strip, and there will be an induced EMF in the Hall strip. Now, using our current equipments and electronic measurement techniques, we can measure the potential difference across two edges of the Hall strip, knowing which we can find the magnetic field flowing through the Hall strip using this basic formula which has been experimentally found. Using this formula, where T is equals to thickness of our Hall strip, we can um, find out the value of external magnetic field. Now, how is the Hall field transistor applied in our daily lives? So we can actually reverse engineer the things that a Hall field transducer does. We can find current through a conducting strip if we apply a known magnetic field to it. Using the formula on the last slide, uh, we can apply a known magnetic field across a Hall strip and find the current flowing through it. We have keyboards where the keys have magnetic fee have Hall strips on the keys, and the bottom at the base of the keyboard we have magnets. When the keys are pressed, the current increases as the field through the Hall strip increases, and that's how the keyboard senses that a button is being pressed. And also Hall field sensors are literally used everywhere. So thank you for the presentation. These are the applications, and these are the references that I used for this presentation.